So last time when we tried to make our own AI camera using ESP32 cam board, we faced a lot of difficulties in building that project. And even after solving all the problems and the issue, the project was still not stable enough to work smoothly. And couple of months later, when I get my hands on this Matouch display with camera from Makerfabs, I thought, what can be the best hardware than this to try making an AI camera once again, which is more stable, as this hardware got better camera, a powerful microcontroller, and also more storage as compared to our previous AI camera hardware. So now let's start our journey of building the AI camera once again with this new hardware, and let's see how many difficulties we faced during its making. So now let me just grab the hardware for this project, and till then you enjoy this informative ad break. This video is sponsored by LTM, and you know what? LTM not just provide world-class PCB designing software, but with LTM 365, they are helping us with the complete electronics product development with really useful collaborative tool. Let me explain how it helps. For example, if you are reviewing a schematic and want to ask a specific detail about the design to, let's say, your software team, well, you can do that here. And later, they'll get an email where they can open the design in a web browser, and they can also get easy access to datasheet of the component to get further information, and later they can update you everything on the same page. In addition, when you send your PCB design to manufacturer, even they can comment down the issues like if the wires are too close to the pad. Even they can search for any specific component or a path like VCC3, and later they can visualize it in 3D to ensure complete accuracy before manufacturing begins. Really useful, isn't it? And you know what's the best part of watching this ad? Well, if you click my link provided in the description of this video, you will not only get the access to free trial version, but you can also get flat 25% off on the license purchase. So do check out the link provided in the description, and now let's move ahead with that video. Okay, so coming back to our video, so now whenever we are trying to make some big project, what we generally do is we try to create the separate code for separate task required in this project, and later we merge all that code together to make the final project. So I will follow the same steps for this project as well. So the first step is we need a code that can live stream the camera onto the display, and by touching a button or touching a screen, we need to capture that image and store it in the SD card. So that's the first task, so let's try to do that. So for that, we modified the built-in example code and added the logic to store image in the SD card, and when we uploaded the code, well, it seems to work completely fine. Like we can stream the camera smoothly, and by just touching anywhere on the screen, the image gets captured and stored in the SD card. So the first step was successful, and now let's move on to the next step, in which we'll need a keyboard through which we can ask our custom questions, and later that question will be sent to GPT-4o for analysis. So for the keyboard, we took the help of the LVGL keyboard example code, and later we flashed it into our board, and this standalone keyboard code was also seems to be working completely fine. So after testing the live camera stream and LVGL keyboard, we thought to merge everything together and start making our end project or the final project. So for that, we decided to add 3 different screens using the Squareline Studio. Out of them, the first screen will have what we can say live stream window, and here we'll have a button called as the capture button. So here we'll be able to see the live stream, and once we click on the capture button, it will redirect us to screen 2, on which here we'll be having what you can say the text box area, and here we'll be having the LVGL keyboard. Okay, and below that we'll have the button called as submit. So once we type the question regarding this image, we'll click on the submit button, and it will redirect us to the screen 3, in which again we'll have a window that will display the still image of the image captured here, and a text box which will have the answer generated from OpenAI. And in the end, we'll have a kind of exit or a restart button, by clicking on which we will be redirected to again screen 1. So this is kind of the thought I have for this particular project. So let's try to design this thing in Squareline Studio, and let's try to upload onto our Matouch display. So we started building the UI in Squareline Studio by creating 3 screens as discussed before. And later, after exporting the code and modifying it to add the live camera stream in it, let's test our final code. And well, the problems started with this as well. So here, as you can see, the camera is streaming at very low frame rate, and not only that, we are also not able to touch the capture button. And now if I start to solve this problem by modifying the code, I know I'll end up making a code that will work but not stable at all, and that is something which I do not want this time. So I decided to check the root level problem in it. So after doing some research about what's going wrong in this, we found the actual issue. So during our research, we found that the issue is with these two libraries, the LVGL and Arduino GFX library. Now here the Arduino GFX library is responsible for the live camera stream on the display. So if I show you that line of code, then here is the line of code which is helping us to display the live camera feed onto our display, and this particular line of code is dependent on the Arduino GFX library, while the LVGL is responsible for all the other UI related things in our project. And we are kind of finding difficulties in merging both of them, like the touch pointers and the touch variables are clashing in between these two libraries. So now the solution that we think of is we need to create the project either by just using the LVGL library or else by just using the Arduino GFX library. So that's what we thought right now. So first we thought to go with the LVGL only, as majority of the tasks like keyboard, text area, button, everything is done in LVGL. So we just need to add the live camera stream in it and we'll be good to go with that. But when we looked over the Squareline Studio, we found that there is no such widget that can help us to show the live camera feed on display. So with that, we won't be able to do the complete project with the LVGL. So the last option was to go with Arduino GFX library. Now the problem with the Arduino GFX library is, like online we get the example codes for everything like text, buttons, live camera stream, everything. But the only code which is not available anywhere on internet is keyboard using Arduino GFX library. So as per our own research, we didn't find any example code which can help us to make a keyboard with the help of the Arduino GFX library. So that is something that we need to do from scratch. So let's start making it. Okay, so here is the code for keyboard using just Arduino GFX, and this code is very simple, straightforward and self-explanatory, so we don't need to go into detail about this code explanation, but I'll discuss some of the important things. So first of all, you need to have this particular boards package version only and these two library with these two specific versions only. Now if you have all these things, this code will compile and successfully upload into your board. After that, one important thing which I need to discuss is this, which is the characters of the keyboards. So as you can see, this is not the standard QWERTY keypad format, rather it is ABCDE format. So why we did that? Well, the thing is, we are going to use this display not in landscape mode but in portrait mode, and in the portrait mode, as you can see, we get limited width, and in the QWERTY keypad the very first line has 10 keys in it. Now adjusting 10 keys is kind of simple, it's not difficult, but accessing those keys will be very difficult because the width of the key will be very small. So what we did is we went for the ABCDE format and we just use 8 keys in single line so that we can get a little bit bigger keys which are easy to access. So for that reason we use the ABCDE format. Other than that, the code is very simple. We are just displaying the keyboard and initializing the touch panel, and whatever we touch, it will be printed onto the serial monitor once we click on the submit button. So that's pretty much it. So now let's see how this code works. Okay, so here is the keyboard that we made with the help of Arduino GFX library, and the touch is kind of smooth and responsive, of course, because it is based on the capacitive touch panel, and it is little difficult to find the keys because we are used to the QWERTY keypad and not this ABCD format. But anyways, we can type anything what we want, and when we click on the send button, the response is submitted here inside the serial monitor, which we can later use for any of our purposes. So yeah, that was the keyboard that we made with the GFX library. So after successfully creating the example code for keyboard, now it's time to move ahead to write the final code of our project, which includes clicking the picture, asking the questions about that picture, sending that request to GPT-4o, and later printing the response from GPT-4o onto the screen. So we started writing the complete code for this project, and while making, we also tried to test and solve all the small issues to make the project smooth and stable. And finally, code is ready. Okay, so here is the final code for our AI camera, and as you can see, it is pretty long code to dig deep into and explain each and everything. So what we did here is we kind of created a flow chart or project flow, you can say, which explains what's actually happening in each and every step. So I'll kind of go through this thing and let you know how things work, and later you can like if you want to modify anything, you can definitely dig deeper in the code and try to modify the way you want. Okay, so let's try with the explanation. So first of all, as we power on the device, it will boot up and it will print connecting to Wi-Fi along with the Wi-Fi credentials that you have provided. And by the way, you can provide the Wi-Fi credentials here, simply like SID name and password, and it will be printing the SID name which you have provided into the screen at the booting time. After that, it will connect with the Wi-Fi and it will display the IP address of it. After the Wi-Fi, it will check whether the SD card is properly initialized or not, because definitely the image that we were capturing, it will be first stored into the SD card before sending to OpenAI server. So we need an SD card. So SD card check is must. So after checking everything like Wi-Fi and SD card, it will start the live camera feed, and it will be done in the format RGB565. Okay. Now why we have mentioned here, well, you'll come to know later while I'll go to the fourth step. But yeah, it will display the RGB565 format, and at the bottom of that what you can say footage will have the capture button through which we can capture the image. Once we click on the capture button, it will freeze the current frame in RGB565 format only, and it will be stored currently inside RAM, inside the temporary storage. Now why? I'll let you know further. So after storing into the RAM, what we are doing next is we are switching it to JPEG mode. Now why we are doing it? So what happens is RGB565 is kind of a compressed version, like a low resolution version that we are storing into the RAM, that we are using for displaying the live stream, so that we can get smoother stream. And the JPEG mode is kind of a high resolution photo, high resolution image that we can use to send it to OpenAI, because that image will contain more details in it. Okay, so that's why once we click on the capture button, within a second it will switch the mode to JPEG and click another in the JPEG mode, which will be a higher resolution image, and that JPEG mode, that high resolution image, will later be saved into the SD card. This is a very important point to be considered. We are not storing the low resolution RGB565 image into SD card. Rather, it is stored in the RAM, while the high resolution JPEG image is stored inside the SD card. After successfully storing it, what we are doing is we are not resuming the live stream. Rather, we are displaying the on-screen keyboard that we have just seen, like this keyboard with the help of Arduino GFX library. With the screen, we'll also get a text area, so we can type any question or a prompt we want, and later we can just click on the submit button or the send button. Okay, so after you click on the send button, what it will do is the image from the SD card is read, and it will first convert it into base64 format. Now, if you don't know about this base64 format, how to convert it and why base64 is important, well, I will definitely recommend you to watch out the very first video about how to send image to OpenAI server and get response from it, because in that video I've talked detail about everything. So I'll attach that link of the video in the description. So do watch that out if you want to understand this base64, understand how OpenAI API works for image analysis. So coming back to this video, after clicking on the send button, we are reading the image stored in the SD card, converting into base64 format. After that, we are using that question that we typed here inside the keyboard into the JSON request, and finally it is sent, like the image and the question is sent to the OpenAI server, to the GPT-4o model. After that, we are waiting for the response, and once the response is received, what we are doing is we are fetching the RGB565 image that we stored inside the RAM under this particular point. We are just reading that, we are again displaying it onto the display, and it will say the status sending to ChatGPT. After waiting for a couple of seconds, we'll get the response from OpenAI, and a textual response is rendered beneath the image, and we can scroll that long message as well, or rather it will be auto scroll, and we can just tap the button to move the text up and down. Okay, it's very user friendly. After that, where there will be a close button appear on the top. When we click on it, we will go back to the very first page of the live stream image, and we can click another image, and can go on and on. So that is the complete explanation of these many line of code written for this particular project. Okay, and to make this project work on your end, you just need to do 3 simple changes. First is the SSID name, second is the password of your Wi-Fi router, and third thing is the API key, which you need to get it from the ChatGPT website, and make sure it is under paid plan, at least $5, because GPT-4o model only works with the paid version of OpenAI and not with the free version. So these things you need to add, and this will work for your credentials as well. Okay, now let me tell you what things you need to take care to make it successfully upload. So first of all, you need to select the right board and COM port, which is ESP32-S3 development board, and later you need to go to tools, select the flash size as this one, select the partition scheme as this one, and select the PSRAM as OPI PSRAM only. Okay, so after selecting all those configuration, you just need to hit the upload button, and let's wait for the code to get uploaded, and later we'll test it out. Okay, so the code was successfully uploaded, and this project is kind of working smooth as well. But now, before I show you the actual working demo of it, I particularly wanted to make this project look more neat and compact, and for that we got the 3D printed case for it, in which we can easily insert the camera on the back and later put the display on the front, and can fix the case with the help of the screws. And now it not only looks neat, but it looks more or less like a tiny smartphone with a bigger camera. Cool. And here, when we powered it up, we found that the live stream was not in proper orientation. And that was obvious because we changed the orientation of camera while fitting it inside the case. So after changing the orientation in the code and uploading the code once again, now it seems to be working completely fine. So now let's take our AI camera version 2 and let's try to test out with different images. Okay, so the code is successfully uploaded, and as you can see, the project started working, and I just love the frame rate. As you can see, we cannot feel the frame refreshing at all. So anyways, let's try to test our project with different sample codes. By the way, I'm powering it up with the help of a power bank. So let's try with the studio photo first of all. So we'll be clicking on the capture button. I'm going to hold this device because it is converting from one mode to another mode, and later saving to RAM and SD card and a lot of stuff going on the back end. So make sure you hold the AI camera to get the steady and crisp image. After that, in a couple of seconds, we'll get the keyboard. So here's the keyboard. Let's try to ask elaborate. As simple as that, elaborate. It's difficult to search for the character, but yeah, that's it. Click on the send button, and now it will, okay, as you can see, it is showing us the image by fetching it from the RAM. Now it is sending it to the ChatGPT, and we'll get the response here. Let's wait for it. Okay, we got the response. The image shows an indoor room setup for a video or photography production. Here are the key elements, and it is a pretty long answer. So it is auto scrolling after every 2 seconds, and let's just leave it as of now. But anyways, we got the response, and if you want to go back, like scroll up, you can just tap here, and as you can see, it's scrolled up, and now it will again scroll down automatically. That's how you can read the responses. Okay, now in case if you want to click another picture, you can click on the cross icon. It will reset all the settings internally, and within couple of seconds you'll get the live stream again, and it's ready to capture another image. Let's just wait for that. Okay, so here it is, live working in action for any other image. Let's try to search for what we can click and ask with this particular camera. Okay, I see a Raspberry Pi sitting here. Okay, so let's try to click the picture of it. Okay, and now let us ask about what is this. Let's see if it can recognize Raspberry Pi or not. Okay, so I'll ask what space is this. Perfect. Click on the send button, and let's see if we get the perfect answer or not. Okay, so the image shows a Raspberry Pi, a small single board computer. It's often used for programming, electronics, electronic projects, and educational purposes. The cables connected to it suggest it might be set up for a network or power connection. Okay, it doesn't just recognize Raspberry Pi board, but it also recognizes the detail of it, which is this wire connected to it. So pretty impressive. Let's try to click on the close button and let's search for any other thing. And for another test, we found this box with the CSK logo on it. So I was wondering if AI camera can detect the CSK team with the help of its logo. So I'll just capture the image and try to hold the camera. Okay, now it's good to go to release it, and let's try to ask which logo. Let's wait for the keyboard to get open. I think it should recognize this, but let's see. Which space logo. Perfect. Let's try to send, and now this image will be sent to ChatGPT, and let's wait for the response. Oh, the logo is for Chennai Super Kings, a cricket team based in India that plays in Indian Premier League IPL. Perfectly recognized by this camera. So that's how you can click any of the image and can ask any question, and hopefully this device will give you the answer of whatever question you asked for regarding that particular image. So that was our AI camera version 2 project. Compact and stable. And now in case if you want to buy this complete project fully programmed along with the 3D printed case, well, you can get one for yourself from our website techiesms.com, whose link you can find in the description of this video. And after purchasing, you just need to do one thing, which is you to share your Wi-Fi credentials and also share the OpenAI key with at least $5 paid plan. You can share those credentials with us and we can program it for you. Test it before shipping so that once it reaches your location, it's ready to be used. So go ahead, get one for yourself because we do have very limited stock of this project. And yeah, in case if you like this project and like this concept, well, do hit the like button and also let me know in the comments about what more improvements can be made in this AI camera project to make it more better. And yeah, that being said, and I'm just ending this video here and now. Just wait for my next video and then explore, learn, share with me, techiesms.